Hello, ladies and gentlemen. Today we are going to introduce the first unit of the course. This is Unit 1, Introduction to Function Analysis. So in this class, we're going to be focusing a lot on functions. So each unit is going to represent various functions and how we apply algebra to those functions. Okay. So today's lesson we're going to cover is 1.1 and 1.2, and we're going to talk about translation, so shifting, reflecting, and stretching graphs of different types of functions, okay? Remember that a function is for every input, there's only one output. So that means that all of these graphs that we have here have to pass a vertical line test, okay? And we'll go into more detail throughout the year about the operations of functions. And especially this, this unit, we are going to hit almost everything pertaining to functions, okay? But before we get started, before we get into more detail into that, we're going to focus more on the graphing aspect of it and being able to graph its parent function along with translations to the function, okay? And then we will also look at piecewise functions and their graphs today too. And for many people, that is a fairly new concept that we will go over, okay? So let's get straight to it. You'll notice that I have up here the worked out notes because it's a little bit easier to share with you, but I'm gonna go through it step by step of how we got through these, okay? So it's a good idea to have the notes in front of you to follow along and to jot down any questions that you have, okay? So first of all, before we get really into this, we need to identify what a parent function is. So the parent function is the most simplest form of a particular function. So for instance, we have a basic square root function. The square root function, notated like this, and it has, it will always start at the origin. So most of these parent functions will start at the origin, and you'll notice that there's nothing happening to it, okay? But when we add or omit things from the actual function, you'll notice that things will change. Okay, so you'll notice that this first one in part B, we have the square root of x, and then outside we have a +2. And we're saying, well, what will happen to the graph? So what I'm going to do is I'm going to share my screen, and I'm going to use Desmos. And Desmos is a great graphing calculator to help us whenever we need to use to see a concept and to be able to graph. Okay, so what I'm going to do is I'm going to type in the parent function, and I'm going to do the square root. I'm waiting for. Okay, so you could type it. You can go into functions here, or you could go in also below here. I'm going to move. I have a box that's in the way. Okay, so there we go. I have my square root. And then from there, I'm going to type in x. Okay, and so it will graph the parent function. You'll notice that it's starting at the origin and nothing's happened. But notice that when I change this function, and I'm going to just label it a different name, and I go into square root of x, and I do +2. You'll notice that we have that same exact f of x. We have the same square root of x, but what happened was it shifted up 2 units on the graph. Okay? So whenever we have a value that's added or subtracted on the outside, whether it's parentheses, a square root, brackets, or anything, that's called a vertical shift. So you'll notice that the y-axis here, it represents vertically. It's a vertical axis. And then our x-axis is our horizontal shifts, okay? And so you'll notice that if I were to change this to a -2, you'll notice that it shifts it down 2, okay? Now, the next thing I'm going to show you is if we have an addition sign inside of the square root or inside of parentheses or whatever, you'll notice that it shifted to the left too. So what I tried to show my students is when you see that it's going to the left, a lot of times students think that it's going negative. Well, it is going into the negative direction, but when we put in values, it's going to give us the negative value here. So notice that this right here, we have x plus 2. If we were to set it equal to 0, you'll notice that the x value, when we get x by itself, becomes negative 2. So we're shifting it to the left too. Okay? Now notice that if I do subtraction, you'll know, you can guess what's going to happen. It's going to go minus 2, so it's going to go to the right 2. Okay, same concept. If you were to set x minus 2 equal to 0 and solve, you'll notice that you'll get a positive x value, being positive 2. Okay, the next thing, which you'll find in your notes, is when you multiply by negative 1 on the outside. So let's say if you have a negative and you have a square root, you'll notice that it's going to flip over the x-axis. This is called a reflection. Kind of like when you look at yourself in the mirror, that image is reflecting back over to you, okay? But this is being reflected over, let's say, the mirror being the x-axis, okay? So this is a reflection over the x-axis whenever we have the negative inside, on the outside. Now notice that if I change that negative and I put it on the inside, like this, you'll notice that it's reflecting over the y-axis, okay? The next thing here is, notice when I plug a value that's greater than 1 inside, you'll notice that it's going to grow a lot faster. Okay? We call this a dilation. Kind of like your eyes, when your eyes dilate, they get bigger or smaller. Okay? So that's the big concept there. Notice that if I were to make this a reflection over the y-axis and then do minus 2 inside, you'll see that it shifted to the left too. And the reason why is because if you were, oh, I was on the wrong page. I was on the wrong slide. Okay, let's go back to our smartboard. Okay, so notice here, if I do the dilation is the value on the outside. Okay, and then right here you'll notice that if I have it reflected over the y-axis and then shifted, in this case it's shifting to the left. And the reason why we say that's going to the left is because when we get x by itself, it's a negative value. So it's shifting to the left. Okay, so just keep that in mind when you're setting these equal to 0 to see whether it's shifting to the left or right. So notice that this one, we know it's reflected over the y-axis, and then it has a plus 2. So if we were to set this equal to 0 and solve for x, you'll notice that that x is positive. So that means it's shifting to the right too. Okay, so there's that. Notice that this one, the 2 tells us that it's a dilation. So whenever we have a value that's being multiplied on the outside, we call this a vertical dilation, meaning that it stretches it vertically. Okay, whereas if it were inside, let's say inside the square root, it would be stretching horizontally. Okay, so it's a good idea to play with this into Desmos. I apologize for you not seeing that earlier, but I'll show it to you just right now. I'll share my screen and we'll go back to the calculator so you can see some of the stuff that's happening. So for instance, let's say I have a square root, like in h of x. So I have the square root, and in our notes we have h of x, and I have a negative on that side, so that means it's reflective of the x-axis. And then I have an x minus 1, and then on the outside is plus 3. So this is telling me that's reflective of the x-axis. Then it's shifting to the right 1. So if you were to set the inside equal to 0 and solve, you notice that it would become x equaling positive 1. So that means it's positive, it means it's shifting to the right. And then this plus 3 means it's going up 3. Okay. So that's that. Very, very important information there. Okay. So let's go back to our notes. Oh, and I also want to, you'll notice that I put the domain and range on here. It's important to understand what domain and range is. So domain is all the possible x values. So when we look at our graph from left to right, we're seeing what x values can we include. So you'll notice that on this graph here of g of x, it's going on forever to the left direction. It's going into negative infinity. It's going to the left forever. So it goes to negative infinity. But then it stops at this x value here, this x value being positive 1. So the domain is every x value from negative infinity to positive 1. After that, you can't graph any value that's greater than 1. So for instance, let's say if you plug a 2 into here, well, negative 2 plus 1 gives us a negative inside the square root. And whenever we have a negative inside the square root, that means we have an imaginary number. That means we can't graph this, okay? The next thing is range. Range is the y values. So what is the lowest that y can go? What's the highest that y goes? So we look at it vertically. So if you look at this purple one, the lowest that y can potentially go is going to be negative 3. And the highest that it's going to go is it's going to keep going up. As the x values are increasing or decreasing, the y value is going to just keep going up. Okay, so we'll cover that quite a bit with domain and range. Okay. You notice that this table is just organizing everything that we just covered. So whenever we have that plus sign that's being added, then we shift up. And whenever we shift it up, that means that we're shifting the y value, because the y value represents the vertical, the graph moving up and down vertically. So we're manipulating the y value. Notice that if it's minus a constant, some value that's a constant, it's shifting it down. So you'll notice that the y value is being subtracted by that constant. Okay. You know, a good way to think of it is if we were to start at 0, 0, where 0 would be x and 0 would be y, your plus c, let it be 2, it would be 0, 2. It shifts it up 2. And if it was minus 2, it would go down 2. Okay. Now, our value inside the parentheses, if that value, when we set x equal to 0, comes out positive, or I'm sorry, comes out negative, then it shifts it to the left. Okay. So if it's shifting left, that means it's horizontal shifts. So that's looking at the x value. You're manipulating the x value. Okay. And then if our inside the parentheses it's minus, then when we set x equal to 0 and we solve, we're going to notice that it's a positive value. So we're adding to that. We're shifting it to the right. All the points that are on the x, we're shifting to the right. Okay. Then if we have a negative on the outside of our function that's being multiplied, that means it's reflected over the x-axis. If it's being reflected over the x-axis, what's happening is our y values are doing the opposite sign. So they're becoming negative. We're switching the sign. Okay. And then if it's inside the parentheses and we have a negative that's being multiplied, then this is called reflecting over the y-axis. It's where we're manipulating the x value. We're changing the sign of the x value. Okay. If we have an absolute value of a function, it's being reflected. A portion of f of x is being reflected over the x-axis, above the x-axis. So all the values all the outputs are gonna be positive. So you'll notice that all of our y values will always be positive if this is an absolute value. Okay. And then a vertical dilation tells us how much how much is our y value being multiplied by. So let's say this a value here was a 2, our y value would be twice that, would be double, okay? So in Algebra 3-4 and in Math, 1-2x, so any math class before this, we've talked about parent functions. So here I've identified parent functions. So this U shape here represents a parabola, which is the quadratic function. You notice that quadratic function, the highest power is x squared. The next one is called an absolute value function. So this is the parent. Notice that these all go around the origin. Now these two functions are very similar because they have this concept of a vertex, meaning the highest or the lowest point on that function. Okay, and they're very similar. If you look at the shape, this is a U, whereas this one's more of a V shape, but they have very similar characteristics. The next one is called a cubed function. A cubed function, and if you notice that the cubed function is a cube root of x. Okay, and so it's this S shape, and then we have over here on to the right is the parent function for a cubic function. So these guys are similar in the fact that they're inverses of each other, meaning that we are manipulating the x and y values. So let's say like we have a value here at x equaling, let's say x equaling 8, the y value is 2. Well, an inverse means that we're flipping the x and y values. So if we had a value of 8, 2, manipulate that, that becomes 2, 8. So if you look here, 2, 8 is up here. Okay, so what it means is it's reflecting over a line called y equals x. And we'll talk about that in future lessons ahead. Okay? So then now it's just describing how the graphs of each of the functions will be different from the basic function. And then we're going to graph them. Okay? So it's important that we know how to graph these by hand without necessarily using a calculator. So the main concept is understanding the parent function. So if we know the parent function, we can do translations to it to be able to graph these. Okay. So the big idea that I get across to students is to pick points that we can manipulate. So let's say, for instance, 0, 0. Well, what happens here is it's shifting to the right 2. I'm sorry, left 2, and then it's going down 3. Okay, so how do we know it's going to the left? Well, if we set the inside equal to 0 and solve, we get a negative x value. We get negative 2. So that means it's going to the left, and then it's shifting down 3. Okay, and so all of these are showing how to graph these. Notice that this is reflected over the x-axis and then shifted to the left 1, and that's going up 4. This one here reflected over the y-axis because that negative is inside, and then it's going to the right 2 because that when we set this inside part equal to 0 and solve, we get positive 2, and then it shifts it to the right 2, and then it goes down 3. This one right here, reflect over the y-axis again, this time shifting to the left 4, and then it's going to go up 1. Okay, so it's just understanding that basic concept of the parent. Okay. This next concept is with a parent function. So I'm going to do this by hand to show you how to do this from a table, and I'm going to do it by hand. So just give me 1 second here as I share my screen, and we'll go to how to do that. Okay, so here we have a table of values here, and we have the coordinate that they gave us was -3, 5. So what I want to do is I want to see, well, what x values are being manipulated with h of x. Okay, well, it's got a vertical dilation, so I'm going to write that. Number one, it's got a vertical dilation. Of 3. Number 2, it's going to be a shift to the left 2. Okay, we know that because if we set the inside equal to 0 and solve, you'll see that it becomes a negative value. And then we have a -3 means it's shifting down 3. Okay, and so what that means is horizontally, if it's going to the left, our points are doing this. They're going, left means -2, comma. Our y value is shifting down, so it's the y -3. So each point is going to be, each point where the x value, it's going to be -2, and then the y value is going to be -3. So if we have a point like this, we're going to take -3 minus 2, and it's going to give us -5. The y value, in this case, actually is going to be multiplying, I forgot the y value multiplied by 3. So the y value is being multiplied by 3. We're multiplying 3 by 5, and then it's -3. So that gives us 15 minus 3 is 12. So our point, when we graph it, is going to be 5, 12. Okay. Now our next point, we're going to take -1. Our -1 minus 2 gives us -3. And then our y value is 3 times 1 minus 3. So 3 minus 3 is 0. And so our point would be -3, 0. So this is very helpful to pick specific points on a parent function and be able to plot those plug those points into our function. Okay, next one, we have a x equaling 1. We're going to plug a 1 minus 2, gives us -1. And then our y value is -4, so 3 times -4 minus 3. And so that's -12 minus 3 is -15. So our point will be -1, -15. And then we have 3 minus 2 gives us 1. And then our y value is 3 times 1 minus 3 gives us 0. So our point would be 1, 0. And then 5 minus 2 gives us 3. And our y value is 2, so that's 3 times 2 minus 3. So 3 times 2 is 6, minus 3 is 3. So our point would be 3, 3. Okay, so these are all points that you could plot onto your graph. And each point would be then a vertical dilation of 3, a shift left 2, and then a shift down 3 to each of these points. Okay, so if we go to this last one here, first of all, when I look at this, number 1 is I know it's reflected over the y-axis. Now, if it's reflected over the y-axis, that means that each of my x values are going to be negative. We're flipping the sign for them. Okay. Number 2, when I look inside the parentheses, that's I need to solve. I need to take the values inside the parentheses and set equal to 0 and solve to see if it's shifting to the left or right. So if I subtract 3 to both sides, I get -3. I'm going to divide by -1. That gives me x equals +3. So if I have a positive, it means it goes to the right. So we know that we're shifting to the right. Okay, so we're going to shift to the right 3. And then on the outside, we have a -2. So we're shifting down 2. -2, down 2. Okay, so we're going to put that kind of all together. If we were to write the point, our x value is negative, or we're changing the sign. It's going to the right 3. So the x value for horizontal, that's the right value, the x value. And then the y value shifting down 2, that would be our y value is going -2. So this is each of our points, we'd be following these rules. Okay, so if I take my x value of -3, I have a negative times a negative plus 3. That gives me 6. And then I have my y value of 5 minus 2 gives me 3. So the point would be 6, 3. Then I have a negative times a negative plus 3. Well, that's 1 plus 3 is 4. And my y value is 1 minus 2 gives me -1. So we have the point 4, -1. Okay. Our next point, we're going to take a negative times +1 plus 3. Well, that's 3 minus 1 is 2. And then we have our y value is -4 minus 2 is -6. So our point would be 2, -6. Then we have our x value of 3, but there's a negative, plus the 3. This gives us 0. Our y value of 1 minus 2 gives us -1. So we have 0, -1. And then our last point, we have a negative times that +5 plus 3 gives us -2. And then we have our y value of 2 minus 2 gives us 0. So the point would be -2, 0. Okay, and these are all the points that you would plot. Very good. Awesome. Okay, now we go into, we're done with that one. Next, we're going to do is we're going to go into piecewise functions for a little bit. And with piecewise functions, this is taking those concepts that we did in transformations and being able to graph them, but they're in segments based on their domain. So what this is saying is that we are going to graph this function, but only the x values that go from -1 to 4. Now, there's a couple things that we need to go over before we start getting into this. First of all, if you see a less than or a greater than, but there's no line underneath it, that means we have an open dot. Okay, open dot. Okay. If we have it with a line underneath it, that means it's less than or equal to or greater than or equal to. This means that we have a solid dot. Okay, so it's a good idea to first plot these values, -1, to plug them into the function here. So if we were to plug -1 into here, -1 minus 2 is -3. -3 squared is 9. 9 minus 3 is 6. So we would plot the point -1, 6. So we're going to go over here and we're going to plot that point. So -1, 6 is right here. But at that -1, we have an open dot. Okay. Then we're going to plot the next value. Like we could plot 0. So you're going to pick random values that are in the interval of here. So if you were to pick, like 0 and put in here, 0 minus 2 is -2. -2, -2 squares 4. 4 minus 3 is 1. So you'd plot 0, 1. Okay. Now, another thing to consider is because this is a quadratic, it has a vertex. So this vertex is opposite x, but keep y the same. So the vertex is that you're going to change the x value. So if this is -2, the x value of the vertex is +2, and you're going to keep y the same. So this is what it's saying is when you go to 2, and then you go down to -3, that's the lowest or the highest point. In this case, it would be the lowest point of the vertex, of this function. That means that this is a turning point. Okay? So just like that. Okay? But we're not done with the interval. It needs to go all the way to 4. Okay? So a good idea is to find the value at 4. So we're going to plug 4 into here. 4 minus 2 is 2. 2 squared is 4. 4 minus 3 is 1. So we're going to go to 4, 1. And that's right here. Now the type of dot we're going to put is a solid dot because it's an equal to. So this is going to go like this, and it's going to come back up, and it's going to have a U shape. Okay? So notice that we have that parabola because it's a quadratic. Now the next piece, this is a piecewise function, next piece is a linear function. But our line is only starting where x is greater than 4. Okay? So I'm going to pick values that are greater than 4, starting at 4. So if I were to pick, and I'm going to do this one in red. Okay? So this one is going to be red. So I'm going to pick values starting at 4. And if I were to put 4 in there, 4 times 2 is 8. 8 over 3. Well, that's a decimal plus 2. So 8 over 3 is like 2 point something. So 2 point something plus 2 is 4 point something. So I'm going to go over here to 4. I'm going to put 4 point something. So somewhere in between 4 and 5. And I'm going to put an open dot. Okay, just like that. And if we want to get technical, that value is going to be 4.666 repeating. Okay. Repeating. Now I'm going to pick another value. It could be any value that's greater than 4 based on what the domain's saying. So I want to pick a value that's divisible by 3. You know, like 9. 9 is a good value. If I plug 9 in there, 9 times 2 is 18. Divided by 3 is 6. 6 plus 2 is 8. So this is 9, 8. So I'm going to look for 9, 8. So it's right here. Okay? And it's a line, so I know it's going to go like this. It's just a straight line that's going to extend through. And there's my piecewise. Okay? Let's go to number 2. So number 2, we have 3 parts. I'm gonna color coordinate these. So the first part is an absolute value. I'm making that one black. Then we have a horizontal line of 3. I'm going to make that one red. And then we have our last one, which is a linear function. And that one I'm going to make blue. Okay, so I'm going to start with each piece, and I'm going to graph them. So this one says that x has to be less than -1. So I'm going to pick x equaling less than -1. So I'm going to do -1, and I'm going to plug it in there. So -1 plus 2 is 2 minus 1, which is 1. Absolute value of 1 is 1. 1 plus 1 is 2. Okay? So I know that that value is an open dot. So I'm going to go over here at -1, and I'm going to put an open dot at 2. So right here, open dot. Okay? Now, I know it's an absolute value function. Absolute value functions kind of look like these. Okay? So I know that it has a vertex. Now the vertex is the opposite x, but keep y the same. So this vertex would be at -2, comma, positive 1. So negative 2, which is less than negative 1, negative 2, comma 1. And so I know it goes like this. And there's a turning point there. So that means it's going to go, all the values up here are going to go increasing. Okay? And I know that it's an absolute value function. So that means that this has a slope of 1. So I'm going to go up 1 each time. And I can extend my line all the way through. Just like that. Okay, so we're done with that part. Now we have this 3. So what it's saying is when x is negative 1, the y value is 3. So when x is negative 1, the y value is 3. So we just put a dot there. Okay. And the last part, we have a linear function that says that x is greater than negative 1. So we're going to put in at negative 1. That gives us negative 1.5 plus 5 is going to be 5.5. Because if you plug negative 1, that would be a positive 1.5, 0.5. And positive 0.5 plus 5 is 5.5. So that value is going to be in between 5 and 6. Okay? Now, good thing with lines is we know how to find points on a line based on slope-intercept form. So the y-intercept is 5. That's the value of y when x is 0. Well, is 0 greater than negative 1? Yes. So we're going to put a point there. And the slope is down 1 over 2. So we're going to go down 1 and then over 2. Down 1 over 2. Down 1 over 2. And then we're going to extend our line all the way through. Just like that. And we're done with our piecewise. Okay? Okay, so let's go to the next one. This next one, we have some square roots. Square roots have a restricted domain on them. Okay? Now this time, it's saying that we're going to pick any x value in between negative 4 and 0. Oh, and this needs to be an open dot here. So I'm going to erase this. I'm going to put an open dot. There we go. Okay. So number 3, we are going to pick values that are in between negative 4 and 0. So I'm going to start with this one, making this one black. This one's going to be red. And then this one's going to be blue. Okay, so I'm going to plug in my negative 4 in here. So if I plug negative 4 in here, that gives me positive 4. So negative 4 gives me a positive 4. Square root of 4 is 2. 2 plus 3 is 5. So the first point I'm going to put is negative 4 comma 5. So negative 4 comma 5. Should be right there. And I'm putting a solid dot. The reason I'm putting a solid dot is because of that line right there. Okay. Now I'm going to plot the point at 0. So if I plug 0 in there, square root of 0 is 0. 0 plus 3 is 3. So I'm going to plot the point 0 comma 3. So I'm going to go to 0 comma 3. And I'm going to only put an open dot because there's not a line underneath it. Okay, and then this is a square root. So I could pick a value in between negative 4 and 0 also. But I need a value that can give me an even number, a whole number inside that square root, like 1. If I plug negative 1 in there, negative 1 with a negative is positive 1. So negative 1 and it gives me positive 1. 1 plus 3 is 4. So I'm going to plot the point at -1, comma 4. So that way I can kind of see that, hey, this is my square root segment. There's my piece of my square root function. Okay. Next one is the red one. It's saying that when x is 0, y is 2. So when x is 0, y is 2. So I just put a solid dot there. And then the next part, we have a square root. This is a square root function that's just being shifted up 3. And it's for any x value that is greater than 0. So if I plug 0 in there, that would give me 3. So we're going to start at 0, comma 3. Put a solid dot there. See how I shade it in between there. Okay. And I'm going to pick values that are going to give me whole numbers in here. So the square root of 1 is 1. So I can do 1. 1 plus 3 is 4. So I know I have 1, comma 4. If I do 2, well, that's going to be a decimal. So I want to do like values that are going to be whole numbers, like 4. So the square root of 4, if I do 4, square root of 4 is 2. 2 plus 3 is 5. So I have 4, comma 5. And I know that this is a square root function, so it's going to do something like this. Okay, and it looks just like that. Okay. Okay, now the last one. Our last one, we're going to put our label ours. So we got this one. This one's going to be blue, and then this one over here is going to be red. Okay, so we have a square root one. And when we graph this one, we're going to pick values that are less than -2. So I'm going to start with -2, and I know there's going to be an open dot there. So I'm going to pick values starting at -2, and I'm going to plug it in there. So -2 and a negative is +2. 2 minus 2 is 0. Square root of 0 is 0. 0 plus 2 is 2. So I'm going to plot 0, -2, comma 2. And I'm going to put an open dot there. Okay. Now I'm going to pick another value that's going to give me a perfect square inside that square root. So I could pick probably, let's see here. I could probably pick -3 in there because -3 is less than -2. If I plug -3 in there, that would give me +3. 3 minus 2 is 1. 1 plus 2 is 3. So I have -3, comma 3. Okay. And then I could do, let's just do one more. Let's do -2 we've already done that one. We want it so that it would give us a perfect square. So if I do, let's do -7. If I do -7, that would give me a +2. That doesn't work. But if we did -10, that would work. So if we do -10 in there, that would give me +10. That would give me 8. So sometimes these are a little bit difficult. Like you could do -11. If you plug -11 in there, it gives you a +11. 11 minus 2 is 9. Square root of 9 is 3. 3 plus 2 is 5. So I do -11, 5. It's way up here. Okay, and then I can graph this just like that. And I'm going to put an arrow because it keeps on going. It's any x value that's less than -2. Okay, now the next one. Next one we said we're going to do in red. We have a linear function. Starts at -2. So if I plug -2 in there, negative 2 in there, that would give me a positive 4. 4 minus 2 is 2. And that is an open dot. Oh, it's right there. Okay. If I pick the y-intercept is 0. So that would be 0, 0, comma, negative 2. So 0, comma, negative 2 is right here. And we can just draw, because we have 2 points, we can just draw our line until we get to x equals 1. So the slope for this is down 2 and over 1. And we put an open dot there. So we're going to put an open dot right here. And we're going to connect those dots there, and there we go. Okay, now the last one. We have where x is greater than 1, and we could plug values in there. So we're going to start with 1, and this is a square root. If we plug a 1 in there, that is 1 minus 1 is 0. The square root of 0 is 0. Negative 0 is just 0. 0 minus 4 is negative 4. So we're going to go to 1, negative 4. Oh, that's right there. Okay, so that's an open dot. Then we're going to do another value that's going to give us a perfect square in there. So I could do 2. If I plug 2 in there, 2 minus 1 is 1. Well, the square root of 1 is 1. Negative 1 minus 4 is negative 5. So I have 2, negative 5. And then I just need one more perfect square. So let's say 5. If I do 5 in there, 5 minus 1 is 4. Square root of 4 is 2. Negative 2 and negative 4 is negative 6. And so I'm going to go 5 comma negative 6. And there's my square root. Try to do an arrow. There we go. Okay, and there's my piecewise for that one. Okay, and that's how you graph piecewise functions. We definitely probably need to do practice over this, do some homework over this, and answer any questions that you may have. So jot down your questions. Make sure you definitely do your homework over these sections, especially the piecewise functions, because if you can get the piecewise functions, I'm pretty sure we can do very well with translations. Okay, we will be doing this we'll be practicing this quite a bit in class. So it's very important that you understand this idea of graphing a piecewise. Okay, I hope you have a wonderful day. Enjoy, and I will. I look forward to hearing from you, and work hard. Okay, and I'll see you later, Mr. Martin out.